Hello everyone, welcome to Jee Mains 2018 offline paper Physics Solutions. Three concentric metal shells A, B and C of respective radii A, B and C, A is less than B less than C have surface charge densities plus sigma, minus sigma and plus sigma respectively. The potential of shell B is: the shell B is inside shell C and outside shell A. Potential at B has three contributions. Potential due to A 1 by 4 pi epsilon naught QA by B, that is 1 by 4 pi epsilon naught sigma into 4 pi A square by B, which comes out to be sigma by epsilon naught A square by B. On similar lines, we have potential due to B minus sigma by epsilon naught into B, potential due to C sigma by epsilon naught into C. So the total potential of shell B will be sigma by epsilon naught A square by B minus sigma by epsilon naught B plus sigma by epsilon naught C, which simplifies to sigma by epsilon naught times A square minus B square by B plus C. 7 identical circular planar discs, each of mass capital M and radius capital R, are welded symmetrically as shown. The moment of inertia of the arrangement about the axis normal to the plane and passing through the point P is: moment of inertia of the system about O, I0 equal to mr square by 2 plus 6 times mr square by 2 plus m into 2r whole square. That simplifies to 55 by 2 mr square. Moment of inertia of the system about P, a parallel axis to I0. So IP equal to I0 plus 7 times mx square. That is 55 by 2 mr square plus 7m into 3r whole square. Take the LCM to obtain 181 by 2 mr square. From a uniform circular disk of radius r and mass 9m, a small disk of radius r by 3 is removed as shown in figure. The moment of inertia of the remaining disk about an axis perpendicular to the plane of the disk and passing through the center of the disk is: moment of inertia of the original disk I1 equal to mr square by 2, that is 9m into r square by 2, mass of the removed portion m equal to small a by capital A into 9m, which comes out to be m. Moment of inertia of the removed part I2 equal to I0 plus mx square, that is a half m r by 3 whole square plus m into 2r by 3 whole square, which is the perpendicular distance between the center of the removed disk and the center of the original disk. Upon simplification, it comes out to be half mr square. So the moment of inertia of the remaining object I equal to I1 minus I2, that is 4 mr square. The reading of ammeter for a silicon diode in the given circuit is: an ideal diode offers zero resistance in forward bias and infinite resistance in reverse bias. As the resistance of the diode is not mentioned, we can consider it to be ideal. The cut-in voltage of silicon diode is 0.7 volts. So applying KVL, we have minus 0.7 minus 200I plus 3 equal to 0, which gives us the current to be 11.5 milliampere. Unpolarized light of intensity I passes through an ideal polarizer A. Another identical polarizer B is placed behind A. The intensity of light beyond B is found to be I by 2. Now another identical polarizer C is placed between A and B. The intensity beyond B is now found to be I by 8. The angle between polarizer A and C is: intensity of incident light on A is I. Intensity of light coming out of A is I by 2. That is intensity of light incident on B. Intensity of light coming out of B, IB equal to I by 2, since the pass axis of A and B are parallel to each other. When C is placed between A and B, intensity of light falling on C is I by 2. The intensity of light coming out of C, IC equal to I by 2 cos square phi, that is equal to intensity of light falling on B. Intensity of light coming out of B, IB equal to I by 2 cos square phi into cos square phi, that is I by 2 cos power 4 pi, Given IB equal to I by 8. So I by 2 cos power 4 phi equal to I by 8, which gives us the value of phi as 45 degree. For an LCR circuit driven with voltage of amplitude Vm and frequency omega naught equal to 1 by root LC, the current exhibits resonance. The quality factor Q is given by quality factor Q equal to 2 pi times energy stored by energy dissipated per cycle, that is 2 pi f naught energy stored by power loss. Quality factor Q equal to f naught by delta f, that is also equal to omega naught by delta omega. Here f naught and omega naught are resonant frequencies and delta f and delta omega are bandwidths. Delta f equal to f2 minus f1, where f1 is lower half power frequency and f2 is upper half power frequency. Quality factor of RLC series resonance circuit Q equal to XL by R, that is omega naught L by R, XC by R, that is 1 by omega naught CR, or 1 by R times root L by C. Two masses M1 equal to 5 kg and M2 equal to 10 kg connected by an inextensible string over a frictionless pulley are moving as shown in figure. The coefficient of friction of the horizontal surface is 0.15. The minimum weight M that should be put on the top of M2 to stop the motion is. As the system is not moving, its acceleration is 0. For the hanging block, M1G minus T equal to M1A, that is M1 of 0, that is 0. For the block on the horizontal surface, T minus F equal to M2 plus M of A, that is M1G minus mu times M2 plus M of G equal to M2 plus M of A, that is 0. M1G equal to mu times M2 plus M of G, from which we get M1 equal to mu times M2 plus M. Upon substituting the given values, we have M equal to 23.3 kg. In a collinear collision, a particle with an initial speed v0 strikes a stationary particle of same mass. If the final total kinetic energy is 50% greater than the original kinetic energy, the magnitude of relative velocity between the two particles after the collision is. Applying conservation of linear momentum, mv0 equal to mv1 plus mv2, that gives us v0 equal to v1 plus v2, squaring on both sides, v0 square equal to v1 plus v2 whole square. Given final kinetic energy is 3 by 2 times initial kinetic energy, so 3 by 2 times half m v0 square equal to half m v1 square plus half m v2 square, which gives us 3 by 2 v0 square equal to v1 square plus v2 square. Subtract 2 v1 v2 on both sides, we have v1 square plus v2 square minus 2 v1 v2 equal to 3 by 2 v0 square minus 2 v1 v2, which gives us v1 minus v2 whole square equal to 3 by 2 v0 square minus 2 v1 v2. From the first equation, v0 square equal to v1 plus v2 whole square, we get v1 minus v2 whole square equal to 3 by 2 times v1 plus v2 whole square minus 2 v1 v2. Upon rearranging these terms, we have the final relation as v1 minus v2 equal to root 2 times v0. A particle is moving with a uniform speed in a circular orbit of radius r due to a central force inversely proportional to nth power of r. If the period of rotation of the particle is t, then central force acting on the particle F is proportional to r power n. So F equal to k by r power n. As the particle is moving in circular orbit, the central force provides the necessary centripetal force, that is mr omega square. So mr omega square equal to k by r power n, omega square equal to k by m into r power n plus 1, which gives us omega equal to root k by m, 1 by r power n plus 1 by 2. So omega is 2 pi by t, so we have t is proportional to r power n plus 1 by 2. Two batteries with EMF 12 volt and 13 volt are connected in parallel across a load resistor of 10 ohm. The internal resistance of the two batteries are 1 ohm and 2 ohm respectively. The voltage across the load lies between. Effective internal resistance R equal to R1 R2 by R1 plus R2, that comes out to be 2 by 3 ohm. Effective EMF E equal to E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2, which comes out to be 37 by 3 volt. EMF equation for a discharging cell is E equal to V plus IR, that is V plus V by capital R into small r, which comes out to be V of 1 plus R by R. So 37 by 3 equal to V of 1 plus 2 by 3 into 10, which gives us V equal to 11.56 volt. So the correct option is 3. In an AC circuit, the instantaneous EMF and current are given by E equal to 100 sin 30t and I equal to 20 sin 30t minus pi by 4. In one cycle of AC, the average power consumed by the circuit and the wattless current are respectively. Average power consumed by AC network, P average equal to Vrms Irms cos phi. Here it is 100 by root 2 into 20 by root 2 into cos 45. That comes out to be 1000 by root 2 watt. Wattless current in AC network, I equal to Irms sin phi, that is 20 by root 2 sin 45, that is 10 ampere. An electromagnetic wave from air enters a medium. The electric fields are E1 bar equal to E01 cos 2 pi nu of Z by C minus T x cap in air, and E2 equal to E02 cos k times 2x minus Ct x cap in medium, where the wave number k and frequency nu refer to their values in air. The medium is non-magnetic. If epsilon R1 and epsilon R2 refer to relative permittivities of air and medium respectively, which of the following options is correct? As the medium is non-magnetic, mu r equal to 1. Speed of electromagnetic wave in air is c. Speed of electromagnetic wave in medium is c by 2 from the given equations. Speed of electromagnetic wave in a medium v equal to 1 by root of epsilon r mu r, that is root of epsilon r in this case because mu r is 1. So speed of electromagnetic wave in air by speed of electromagnetic wave in medium is c by 2, that is 2 equal to root of epsilon r2 by epsilon r1. So epsilon r1 by epsilon r2 equal to 1 by 4. A telephonic communication service is working at a carrier frequency of 10 GHz. Only 10% of it is utilized for transmission. How many telephonic channels can be transmitted simultaneously if each channel requires a bandwidth of 5 kHz? Frequency of the carrier wave is 10 GHz. Frequency utilized for the carrier wave is 10% of it, that is 1 GHz. Channel bandwidth required is 5 kHz. So the number of channels n equal to f by delta f. That comes out to be 2 into 10 power 5. A granite rod of 60 centimeters length is clamped at its midpoint and is set into longitudinal vibrations. The density of granite is 2.7 into 10 power 3 kg per meter cube and its Young's modulus is 9.27 into 10 power 10 Pascal. What will be the fundamental frequency of longitudinal vibrations? Length of the granite rod L equal to 60 cm. Wavelength of the stationary wave formed is lambda by 2 equal to 60. From there lambda equal to 120 cm. Speed of the longitudinal wave V equal to root of y by rho, which comes out to be 5.86 into 10 power 3 meter per second. So the frequency of the wave F equal to V by lambda, that is 5.86 into 10 power 3 by 1.2, which comes out to be 5 kHz. It is found that if a neutron suffers an elastic collinear collision with a deuterium at rest, fractional loss of its kinetic energy is Pd, while for its similar collision with a carbon nucleus at rest, fractional loss of kinetic energy is Pc. The values of Pd and Pc are respectively. Initial kinetic energy of the neutron K initial equal to half mn u square, that is u square by 2. Velocity of the neutron after colliding with the deuterium V equal to mn minus md by mn plus md of u, that is 1 minus 2 by 1 plus 2 into u, that comes out to be minus u by 3. Kinetic energy of the neutron after collision K final equal to half mn v square, that is half into 1 into u square by 9 that is u square by 18. Fractional loss of kinetic energy Pd equal to K initial minus K final by K initial, which comes out to be 8 by 9, that is 0.89. You can carry out a similar calculation with carbon atom, in which case the fractional loss of kinetic energy comes out to be 0.28. The density of a material in shape of a cube is determined by measuring three sides of the cube and its mass. If the relative errors in measuring the mass length are respectively 1.5% and 1%, the maximum error in determining the density is. Relative error in measurement of mass delta m by m into 100 equal to 1.5%. Volume of the cube V equal to L cube. Applying log on both sides, we have log V equal to 3 log L. Differentiate to obtain delta V by V equal to 3 times delta L by L. Relative error in measurement of volume delta V by V into 100 equal to 3 times delta L by L into 100, that comes to be 3%. Density of the cube rho equal to m by V. Log rho equal to log m minus log V, that is log m minus 3 log L. So delta rho by rho into 100 equal to delta m by m into 100 plus 3 times delta L by L into 100, which comes out to be 4.5%. 2 moles of an ideal monoatomic gas occupies a volume V at 27 degrees centigrade. The gas expands adiabatically to a volume 2V. Calculate the final temperature and change in internal energy. In adiabatic process, we can write Tv power gamma minus 1 equal to constant. So T1 V1 power gamma minus 1 equal to T2 V2 power gamma minus 1, that is 300 V power gamma minus 1 equal to T2 into 2V whole power gamma minus 1, which gives us T2 to be 189 Kelvin. Change in internal energy for adiabatic process du equal to minus dW. Work done dW equal to NCV dt. That is in fact change in internal energy. Take the given values to have the answer 2768.56 joule. A solid sphere of radius r made up of a soft material of bulk modulus K is surrounded by a liquid in a cylindrical container. A massless piston of area A floats on the surface of the liquid, covering the entire cross section of the cylindrical container. When a mass m is placed on the surface of the piston to compress the liquid, the fractional decrement in the radius of the sphere is pressure acting on the liquid delta P equal to F by A, that is mg by A. Fractional change in volume delta V by V equal to 3 times delta R by R. Bulk modulus K equal to delta P by minus delta V by V, that gives us delta R by R equal to mg by 3 Ka. A parallel plate capacitor of capacitance 90 picofarad is connected to a battery of EMF 20 volt. If a dielectric material of dielectric constant 5 by 3 is inserted between the plates, the magnitude of the induced charge will be. Charge on the capacitor before inserting the dielectric Q1 equal to CV, that is 19 to 10 power minus 12 into 20, which comes out to be 1.8 nanocoulomb. The charge on the capacitor after inserting the dielectric Q2 equal to C dash V, that is K times C into V, which comes out to be 3 nanocoulomb. So the additional charge that has gone into the capacitor Q equal to Q2 minus Q1, which is 1.2 nanocoulomb. The dipole moment of a circular loop carrying a current I is M and the magnetic field at the center of the loop is B1. When the dipole moment is doubled by keeping the current constant, the magnetic field at the center of the loop is B2. The ratio B1 by B2 is dipole moment of a loop M equal to I into A, that is I into pi r square for circular loop. Magnetic field at the center of the circular loop is mu naught I by 2r. The relation between magnetic field and dipole moment is B equal to mu naught times root of I square pi by 2 root m. So B is proportional to 1 by root m as current is maintained constant. So B1 by B2 equal to root m2 by m1, that is root of 2m by m, which comes out to be root 2. An electron from various excited states of hydrogen atom emit radiation to come to the ground state. Let lambda n, lambda g be the de Broglie wavelength of the electron in the nth state and the ground state respectively. Let lambda n be the wavelength of the emitted photon in the transition from nth state to the ground state. For large n value, a and b are constants. Then lambda n comma lambda g are de Broglie wavelength of the electron in the nth state and ground state respectively. Capital lambda n is the wavelength of the emitted photon in the transition from nth state to ground state. De Broglie wavelength in ground state 2 pi r naught equal to 1 into lambda g. De Broglie wavelength in nth state is 2 pi rn equal to n lambda n, that is 2 pi n square r naught equal to n lambda n equal to lambda n by lambda g. Applying Rydberg formula, 1 by capital lambda n equal to r of 1 by 1 minus 1 by n square, that is r of 1 minus 1 by n square. So lambda n equal to 1 by r of n square by n square minus 1. Upon simplification, it comes out to be capital lambda n equal to a plus b by lambda n square. The mass of a hydrogen molecule is 3.32 into 10 power minus 27 kg. If 10 power 23 hydrogen molecules strike per second, a fixed wall of area 2 cm square at an angle 45 degrees to the normal and rebound elastically with a speed of 10 power 3 meter per second, then the pressure on the wall in Newton per meter square is nearly. Mass of each hydrogen molecule is 3.32 into 10 power minus 27 kg. Initial momentum of each molecule is mv, that is 3.32 into 10 power minus 27 into 10 power 3, that is 3.32 into 10 power minus 24 kg meter per second. Total initial momentum along the normal n into mv cos theta. Change in momentum per second is force 2mv cos theta, that is 2 into 10 power 23 into 3.32 into 10 power minus 24 into 1 by root 2. Pressure acting on the wall P equal to force by area, which comes out to be 2.35 into 10 power 3 Newton per meter square. All the graphs below are intended to represent the same motion. One of them does it incorrectly. Pick it up. From the third graph, it is evident that we are talking about vertically projected body. Fourth graph, as the body moves up, its velocity decreases, becomes 0 at the highest point and then increases as the body comes down. Second graph, displacement of a vertically projected body h equal to ut minus half gt square, that is parabola. So the incorrect graph is first one. An electron, a proton and an alpha particle having same kinetic energy are moving in circular orbits of radii Re, Rp and R alpha respectively in a uniform magnetic field B. The relation between Re, Rp and R alpha is radius of the circular path followed by a charged particle in uniform magnetic field R equal to mv by bq, that is p by bq, that is root of 2mk by bq. Since all the particles are in same magnetic field with the same kinetic energy, R is proportional to square root of m by q. Taking the ratio, Re is to Rp is to R alpha equal to root of me by qe, root of mp by qp, root of m alpha by q alpha. Upon substituting the values, we have the ratio to be 1 by 43 is to 1 is to 1, which gives us Re is less than Rp, that is equal to R alpha. On interchanging the resistances, the balance point of a meter bridge shifts to left by 10 cm. The resistance of their series combination is 1 kilo ohm. How much was the resistance on the left slot before interchanging the resistances? Let the resistance in the left gap and right gap be x and y respectively. Bridge balance condition x by y equal to L by 100 minus L. After interchanging the resistances, it is y by x equal to L minus 10 by 110 minus L. Series combination R equal to x plus y, that is 1000 equal to x plus y. From the first condition x by y equal to L by 100 minus L, we have x equal to 10L. From the second condition 1000 minus x by x equal to L minus 10 by 110 minus L. from where we have L equal to 55 centimeter. So the resistance in the left gap before interchanging X equal to 10L, that is 550 ohm. In a potentiometer experiment, it is found that no current passes through the galvanometer when the terminals of the cell are connected across 52 centimeters of the potentiometer wire. If a cell is shunted by a resistance of 5 ohm, the balance point is found when the cell is connected across 40 centimeters of the wire. Find the internal resistance of the cell. Balancing length of the potentiometer for the cell is 52 centimeter. Balancing length of the potentiometer of the cell with resistance is 40 centimeter. So the internal resistance of the cell small r equal to capital R times L1 minus L2 by L2, which comes out to be 1.5 ohm. If the series limit frequency of Lyman series is nu L, then the series limit frequency of the Fund series is. Applying Rydberg formula, 1 by lambda equal to R of 1 by n initial square minus 1 by n final square. So nu equal to C by lambda, that is RC times 1 by n final square minus 1 by n initial square. For series limit of Lyman series, we have n final is 1 and n initial is infinity. So nu L equal to RC times 1 by 1 minus 1 by infinity, that is RC. For series limit of Fund series, n final is 5 and n initial is infinity. So nu Fund series equal to RC times 1 by 25 minus 1 by infinity, which comes out to be RC by 25. So it is equal to nu L by 25. The angular width of the central maxima in a single slit diffraction pattern is 60 degree. The width of the slit is 1 micrometer. The slit is illuminated by monochromatic plane waves. If another slit of same width is made near it, Young's fringes can be observed on a screen placed at a distance of 50 cm from the slits. If the observed fringe width is 1 cm, what is the separation between the slits? Condition for diffraction minimum, A sin theta equal to m lambda, that is 1 into 10 power minus 6 sin theta equal to 1 into lambda. So lambda equal to 0.5 into 10 power minus 6 meter. Fringe width of Young's double slit experiment, beta equal to lambda d by d, that is 1 into 10 power minus 2 equal to 0.5 into 10 power minus 6 into 0.5 by d, which gives us the separation between the slits to be 25 micrometer. A particle moving in a circular path of radius a under the action of attractive potential U equal to minus k by 2r square. Its total energy is. Force acting on the particle F equal to minus du by dr, that is minus d by dr of minus k by 2r square, which comes out to be minus k by r cube. This force provides the necessary centripetal force. So k by r cube equal to mv square by r, from where we get kinetic energy equal to k by 2r square. So the total energy, potential energy plus kinetic energy, k by 2r square minus k by 2r square, which is 0. A silver atom in a solid oscillates in simple harmonic motion in some direction with a frequency of 10 power 12 per second. What is the force constant of the bonds connecting one atom to the other? Molecular weight of silver is 108 and Avogadro constant is 6.02 into 10 power 23 gram per mole. Frequency of oscillation F equal to 1 by 2 pi root k by m. Here k is force constant and m is mass of the oscillator. Number of moles small n equal to capital N by Na. That is also equal to m by capital M, where capital M is molecular mass. From which we get mass equal to 1 by 6.02 into 10 power 23 into 108 into 10 power minus 3 kg, which comes out to be 17.94 into 10 power minus 26 kg. From there, we can write frequency F equal to 1 by 2 pi root k by m. 10 power 12 equal to 1 by 2 pi root k by 17.94 into 10 power minus 26, which gives us the value of k to be 7.1 Newton per meter.